about really get into how logarithm graphs change and stuff with transformation. All right, so if you would take some kind of a function, and I would say, let's say this was the function y equals b to the x. This is an exponential function, correct? And the base is b. And this would go through the point 0, 1, because anything to the 0 power is 1. And then if I would put one more point on here, whatever the first power would be it would be the base, correct? So if I put 1 in for x, this would be 1 whatever b is. Are you following there? Okay. So earlier on in the year we talked about these things called inverses. And inverses, will you tell me what you remember about inverses? What happened? We talked about lots of different things that happened, but give me one thing that happened.
Does it reflect it over the axis?
Good. It reflects it not over the axis, but over the line y equals x. So here's the line y equals x. Okay? And so I'm going to draw this over here, but if I would reflect this curve over this line y equals x, what happens is, do you see what kind of where I'm drawing my pen right there? It's going to look like that instead. All right. What else? What happened with the equation? Do you guys remember how I said, hey, find an inverse? How did we do that? We had to reverse them. The y and the x. So instead of y equals b to the x, what could I write? X equals b to the y. And actually, if I went through and did the ordered pairs would also all be switched. So this point 0, 1 would become, reverse it, 1, 0. So it would be like right here. How about this point 1 comma b? What would that become? B comma 1. Okay, so I don't know how far b is, but 1's like this. And then instead of curving like this, it would curve like that. Instead of having a horizontal asymptote, it has a vertical asymptote. And this is actually the exponential function, or the exponential form of a logarithm. This is its exponential form, and then I'll ask you to write it in logarithmic form, which is y equals log b of x. So let's just point out some things here. I lost my yellow highlighter, and I don't like it. Let's do colors. All right. Do you see this base right here? It shows up down here. So whatever this little number is, that's the base of your exponent. And the exponent itself is right here, and it shows up on the other side of the equal sign. Okay. All right, so here we go. That's kind of my introduction to it, and let's do a definition then. So first of all, I hope you notice over here, do you see how the log is always positive? In fact, it's never 0 either. It's always to the right, the x's anyways. So as long as x is greater than 0, and b is between or greater than 0 and not equal to 1, then if you see this, y equals log base b of x, if and only if b to the y equals x. So I would put these two statements right next to each other. This is logarithmic form. This is exponential form. Okay, and so I gave you some things in the opener that were some basic ideas, but like I'm going to rewrite some of them now in logarithmic form. You see that one, the first one was 2 to the x equals 8, and you guys told me that x was 3, right? If I wanted to write that in logarithmic form, I would make the base be the base of that. So this would be log base 2. So log base 2 of 8 equals 3. Why? That's this logarithmic form. Because 2 to the third equals 8. Let's do the second one we did in the opener. How do you think I'd write that one? 3 to the x equals 9. What's the base of the exponent? So I'm going to write log base 3 of 9, good, equals 2. So the power goes on the other side of the equal sign. And then its exponential form is 3 squared equals 9. Okay, let's move along. Let's do one more. So how about 5 to the x equals 1 over 25? 5 to the negative second equals 1 over. How would I write that? Log base 5 of 1 over 25 equals, and what power did we get? Negative 2. Okay. And so then, and we just got to make sure we take our time remembering where does it go? Does it go on this side of the equal sign or on the other side? All right, so let's go and then do some general properties, and then we should talk about the two logarithms that you see on your calculator, because these I can do in my head, hopefully, small powers, but then there's log, which is log on your calculator, and ln. So, all right, first of all, let's just talk about any properties in general. Do you guys have any questions so far? Okay. All right. So, the first property is that the log base b of 1 equals, okay, so this is what I'm asking you. If the base was b to what power is going to give you a 1? 0. So if I ever ask you to evaluate a logarithm of 1, the answer to that is going to be 0, because the logarithm itself is the power. So the reason why is because b to the 0 equals 1. Okay. Then the log base b of b is always, if you have the log of itself, what power gives you itself? 2 to what power is 2? 3 to what power is 3? 1. So if you have a logarithm of the same base, then it's always going to be 1. Why? Because b to the first equals b. So that's our second property. The third property we're going to use probably towards the end of the week. This is the most useful property of a logarithm. Do you remember how I told you the logarithm is just the power? So the log base b of b to the y, what should the answer to that be then? B to what power is b to the y? B to what power is b to the y? Why? It's just the power. and this actually gets into the property of, you remember how I said they were inverses of an exponential function? Didn't the log just undo the exponent? Okay, it's inverse. So the reason why, rewrite it in exponential form. B to the y, oh yeah, equals b to the y. Okay, then the last one, ooh, I can squeeze it in here. The last one probably isn't going to make so much sense to you unless you think of it as an inverse. So if something's an inverse, when you put it into the other function, shouldn't you get x back, or whatever, the variable back? I had you guys do that in chapter 1. So if I said, what's b to the log base b of x? It's just x. Because log base b of x equals log base b of x. So not only if you raise a log, if you do a log of an exponential, does it cancel it? But if you do an exponential of a log, same basis, it also cancels the logarithm out. Okay. So let's try some without our calculators. You can't use your calculators for bases other than 10 and 8, because there's no such thing. I don't think. I think maybe last year somebody told me on the those really fancy, the Inspires. Does anybody have one of those? The TI Inspire. I think somebody told me that they have a log of a different base, but I don't know. Okay, so let's try a couple, and then I think the best thing to do is we'll just do some whiteboard practice when we're all done to practice. What is, let's do the log base 8 of 8. So what's on the other side, which I'm trying to find, is the power. What do you think it is? 10? 1. Because 8 to the first is 8. Good. And if you want to write that next to it, what you're finding is that. Okay. Okay, how about log base 14 of 1? What's the base? 14, I'm trying to figure out the power that gives me a 1. 0. Okay. Alrighty, how about log, because I think that we're up for the challenge, log base 2 of the square root of 2. Can you rewrite the square root of 2 as a power? The 1/2 power, right? This is the same as log base 2 of 2 to the 1/2. That's what that means. So what power is it? It's the 1/2 power. Alright, so you should be able to rewrite, you should be able to do radicals and also reciprocals. Should we do a reciprocal one? Log base 3 of 1 over 27. What do you think that is? So, Bobby, -2 would be 1/9. So you're getting close. You're on the right track with the negative. -3. Well, 3 to the third is 27, right? So isn't 3 to the -3 1 over 27? All right, and we're looking for the power. If you want to know why, you would say 3 to the -3. The thing you're finding is the power, is 1 over 27. Okay, We'll do some more of that in a second. Would you guys take out your calculators, please, and on your calculator, let's find the two more things.